Welcome to this edition of Fuel for Thought, where this week we are live from the show floor at CERAWeek, the energy industry conference where hydrogen is in the air, as are methanol, lithium, and even ammonia. Although CERAWeek's history has pegged it as an energy conference, the interdependence of the extraction and commodities industries to the automotive world has become more intensive and will continue to evolve. S&P Global Mobility was part of the massive team that presented CERAWeek 2023 in Houston in March. More than 8,000 delegates and 1,000 speakers packed the George R. Brown Convention Center and Houston America's Hilton for 5 days of sessions from the industry C-suite. And if you're listening to this podcast, you probably missed the convention, and you're wondering what happened there. Well, you're in luck because you're about to get a proper refining and distillation. I'm Mark Recton, Executive Editor of S&P Global Mobility, and this is Fuel for Thought. While there was much discussion of how the world will get its next fix of oil and copper, there also was a recognition of sustainability and how to keep the climate from spiraling out of control in the process. That leads to the key subject of electric vehicles. With BEVs now becoming a mass-market transportation solution in China and Europe and quickly gaining ground in North America, a hot subject was how to provide the key elements and minerals that comprise their batteries, motors, inverters, and the like. S&P Global Mobility forecasts market demand of about 3.4 terawatt-hours of lithium-ion batteries for light vehicles annually by 2030. However, the 2021 output for the auto industry was a meager 0.29 terawatt-hours. So it's not just a matter of dig faster, dig deeper. Richard Kim, Associate Director of Research and Analysis at S&P Global, provides some sobering news on this front.
When it comes to whether the new miners can bring the materials in 5 years or 10 years, it sounds like a very difficult part. They need a permitting. They need to build the infrastructure, financing, all those stuff will take some time. The lead time is really, really long, like 15 years, 20 years. Yeah, it's going to be really challenging, even though there are several announcements from Iran, India, and the other countries found a new deposit in their country. In that sense, even though the minings are found in the right countries, but Australia or something, then it will take more than 10 years or so. So I think this is very, very unhappy news.
So that takes us back to the issue of supply and demand. We have currently what we are pulling out of the earth is nowhere near what we're going to need to be pulling out of the earth every year. So that means we aren't going to have these ethically sourced rare earth elements coming to the surface in sufficient time. So that means we are having to use bad actors, so to speak, or at least companies or countries that don't have the same ESG concerns or sustainability concerns that we would like them to have. So how do we get that right in our heads?
I think we need to have some sort of distinctions, new minings, whether they're going to be ethically feasible mines or not. But when it comes to real life, when you talk about the 2055 or 2030, we have some deposits here and there, which is ethically available. But the problem here is that the market is going to be really, really tight. The supply is going to be really, really tight after 2025 or so. So when I talk to the OEMs or suppliers, I usually say that, if there is a issue with raw materials, we need to expect a deficit, then OEMs should find the solutions. Probably they can lower the battery capacity per vehicle, or they can use the other materials like, LFP, or as JAC Auto introduced in the China market, they can use sodium-ion batteries in the, cheaper segment.
Even once the vehicles do arrive, how to charge them was a hot topic at many of the CERAWeek sessions. Graham Evans, director of the Auto Supply and Technology team for S&P Global, is on the front lines of the EV charging discussion, both in terms of what consumers want and what infrastructure engineering companies are able to provide. And as BEV sales accelerate from single-digit share into the mass market, what has been a boutique charging business is going to have to scale massively.
The vast majority of charging is and will continue to take place at home. And yet at the same time, we're making huge advancements in terms of understanding what consumers need, what this next generation of, let's say, perhaps more skeptical adopters, less people a bit less willing to change their typical behaviors, what they need from the charging experience. And of course, even if people do charge at work or they do charge at home, having prevalent, available, reliable public charging infrastructure is going to be really critical to ensuring that those people embrace an EV and they continue to drive an EV. We need more technology, more available charging infrastructure and better technology in the places where these people live. And that can be residential, apartment blocks. This can be at the workplace for these people who are charging, they're getting their charging needs predominantly from where their car will dwell at work. So we need more of that, more solutions in the locations where people will dwell, and then to facilitate the longer distances, to ensure that people can use their EV in every situation, every environment. We need that affordable, prevalent, fast charging infrastructure at the key points along the major highway routes.
There's also some discussion about usability and functionality of these out in the world chargers, especially when they don't work, credit card reader doesn't work, or the connection between the car and the charger doesn't work. And this is prompting a lot of complaints we're seeing on the internet, on the chat rooms, and this is with zealots. Yeah. So if all of a sudden you're crossing the chasm into the mass market and the people can't figure out why the credit card reader doesn't work, what sort of complications does that bring to the market?
Obviously, there's a software aspect to this and there's a hardware aspect to this. And actually, in the vast majority of cases, when the electric vehicle charging experience fails, it's software and it's relatively easy to resolve. It's actually not the case that often at all you need to send someone out to repair something on the station. So we need to find a way to overcome these bugs. We need to find a way to understand the failure mechanisms and improve it. AI is a big part of this. These companies like Drives are leveraging a huge amount of historical data now in order to improve the charging experience moving forward and understand the failure modes. So on the software side, yes, getting better. On the hardware side, seamless payments, being able to pay at a charging station without needing to own, multiple different RFID cards for different networks. The industry needs to get away from this so quickly in order to make it a more seamless experience. It should be just as easy as filling up with gasoline.
The early adopters have benefited from incentives, but mostly they've been tax breaks for rich people. So what do you do in the case of trying to spread the message to the lower income crowd for whom the idea of spending $1,000 to $1,500 to upgrade their home's panel is just completely out of the question? Do you see government incentives to help lower income people get home charging in place?
To a degree, the government has to take responsibility for making sure that the infrastructure is in place to facilitate EV adoption for everyone. And of course, there's upfront investment required for that. If you really want to make this mass market, that definitely needs to continue. We need to really understand what consumers want, where they will charge and how they will charge, and make sure that the funding and the subsidies and the incentives are directed at that next wave of adopters who, they can't afford a Tesla, but they want to get on board and buy into this EV experience, this EV ownership, do the right thing, and from a climate perspective.
So, Graham, there's a lot of conversation about people and charging networks and how they charge their EVs, and they look at a parking lot with 10 chargers and just think they suddenly appear. Creating charging infrastructure is much broader scale than that.
Absolutely. I think one of the things we've been able to put out there in the open for everyone to see today is there's such a multitude of stakeholders involved here to go from plans conception through to delivering the infrastructure we need to charge electric vehicles. And some of these roles are quite discrete. So the involvement, let's say, of the grid operators, of the engineering companies that facilitate all of this, the back-end station operators, as well as the charge point operators themselves. And of course, the OEMs have a role to play here too, obviously, not just in terms of finance, but also in terms of involvement and making sure that their vehicles can interact with the grid effectively.
So one of the things that were discussed is permitting. So in the city of Los Angeles, you have the city of Los Angeles, but then you have all these suburbs that may have their own permitting and planning processes. And if, say, you're a giant charging company, you might have to deal with a bunch of different city planners, all with their own regulations. And how does that help or hinder being able to establish an actual charging grid for a major metropolitan area?
I suppose the simple answer to the question is that it does absolutely hinder things and it slows things down. And this is so complex, the number of different organizations involved and having to do things differently when you operate in a slightly different geographic area or jurisdiction, as you mentioned. There's definitely an appetite and an enthusiasm to work through this. And actually, we've got some pretty huge companies involved in this space now. This isn't some like kind of local thing going on between a few people who want to promote EVs in a local area. We've got huge multinational construction companies who are getting stuck into this challenge, who want the business, who want to support the rollout of electric vehicle charging infrastructure. And that's really going to help us move things much quicker.
So yeah, we're bringing up scale, and that includes things like construction materials and manpower. We have a forecast that's talking about how many millions of chargers we're going to need in very short order. How do you marshal those resources to make a statewide, region-wide, nationwide charging network work?
In a way, it's a classic supply chain challenge as we embrace a new technology and we try to scale up. And of course, people think about the end product perhaps, or they think about some of the critical materials along the way that can hold up a supply chain here. But I mean, in this particular case with charging stations, there's a multitude of things, even if it's copper for the transformers or something that might seem relatively innocuous, this could be the supply chain bottleneck that really, really holds things up. So we have a multitude of different stakeholders. They all have their respective challenges. They all need materials. They all need labor. They need, skilled labor. They need to bring together all of these different sort of facets of it, and in order to be able to deliver infrastructure at the scale we need. I mean, the calculations suggest that somewhere in the region of 240 stations a day are being installed in the US. I mean, we need much more than that. So the sheer manpower and coordination required in order to deliver this charging infrastructure and facilitate the levels of adoption we have in our forecast is massive. But I mean, yeah, the good news is that people are up for the challenge and people understand the challenge.
Okay, so then we get the network up and going. Now it needs to talk to the grid. And yes, there's all sorts of very excellent, complicated software that will allow to plan for pretty static events. Of course, there's already been a lot of hysterical headlines about, the next time there's wildfires or a heat wave, it's going to crash the grid when you have hundreds of thousands or millions of EVs on it. What are some of the solutions that are being proposed in order for the grid to maintain stability when all of a sudden there's this excess drain?
I mean, the numbers are huge. I mean, a couple of megawatts, if you've, let's say, 150 kilowatt EV charging, you have 10 of them, you got 1.5 megawatts. That's the size of a small neighborhood almost, or a huge building, right? A huge skyscraper. So once you've got several medium heavy duty vehicles charging simultaneous and you're drawing 20 megawatts, that's the size of a decent town. Putting in place the grid that will be able to cope with that and deliver that power. And obviously it's an kind of on-off kind of power challenge, really. It's not like a constant draw. This poses a real challenge in terms of, how do we provide for that? Who pays for that? Not just in terms of installing the infrastructure, but also in terms of the operation of the grid, to provide that level of power on a consistent basis when it's needed, maybe to like a, medium heavy duty depot for like a, let's say a major logistics company. This is massive, but I would say that the key thing we're learning is that people are using data. They're using our forecast sometimes even to project, further out and understand that demand and work back from that to say, okay, what do we need to put in the ground now to facilitate that level of adoption? And of course, this is all interlinked to the targets and everything, related to the wider, aspiration here from a climate change perspective to meet those targets. So, if the right people are asking the right questions and doing the right things, we definitely need more people. We'll definitely need some more resources, I think, to get this done.
So that handles all the new vehicles coming to market. But what's to be done with the existing vehicle fleet? Shi Huang, Principal Research Analyst in the Sustainable Mobility Group at S&P Global, provides this context.
In 10 to 15 years, the new car fleet will be reduced by about 75% of tailpipe emissions. However, for the major markets, EU, US, and mainland China combined, we have only like 45 to 55 million cars go into the market as a new car, but we have about 1 billion cars on the road. That's the huge in-stock ICEs running on the road. So when it combines, that slows down the sectoral decarbonization pathway. Is not going to be as fast as the new car fleet. So we'll need flexibilities and variety of ideas on how to power all those in-stock cars.
Then there's Jeff Meyer, Director of Mobility and Energy Future at S&P Global, who discussed retrofitting the existing internal combustion vehicle fleet to be cleaner burning.
Even if you go really fast in terms of electrification, new sales, and that does translate into the fleet, there's a lot of fleet that will take a very long time. And it sort of speaks to the polyfuel concept, and also a question of regional differences and regions moving at different speeds. In the shorter term, something like more biofuels, and then in maybe quite the longer term, e-fuels. One of the big differences is the rise of renewable energy, and the fact that now synthetic fuels can be carbon neutral. And it's just interesting, just in the news, that the EU, that Germany, among others, at the last moment, has intervened and kind of paused the finalization of the CO2 standards there to maybe have a clause that would allow for use of e-fuels and ICEs beyond 2035. There's going to be potentially some course corrections, whether it's actually California and CARB in their 2035 goals, and sort of, in the interim, maybe we need to, maybe allow a little bit more flexibility for PHEVs or that kind of thing. And even with the EU, even when it's finalized, there are reviews. So you kind of, got to take things step by step. And that's why also I think will be interesting to look at some of the interim targets, let's say, that OEMs have and energy companies have, as opposed to 2035 targets, or much less 2050 targets.
Which brings us back to hydrogen. And if you've been following the alt-fuel scene, you probably remember a lot of fuss being made about hydrogen and hydrogen fuel cells about a decade ago. Then things got quiet as Tesla and other battery electrics took over the spotlight. But that's in passenger cars. And for all the ruckus Elon Musk is making about Tesla's battery entry into the heavy-duty segment, hydrogen is making a resurgence as a viable long-haul trucking option to replace the traditional diesel engine. Edward Tavernier, president of S&P Global Mobility, discusses how hydrogen is making a comeback of sorts.
Where we see it is that it's not going to play much of a role in the passenger car market for a variety of reasons, but mainly because BEV is emerging as the dominant kind of choice by the industry, right, to reduce carbon emissions. And while we do see it playing a role in heavy-duty applications, these new hydrogen hubs, which are being incentivized by the IRA in the US, I think there's lots of positive momentum around these. That will take time. It is more complicated to build that distribution infrastructure. And I don't want to underestimate the power of incentives and technology. I think we see distribution as being a bit of an insurmountable issue today for hydrogen, but it could be bridged, right, in the next few years. Permitting is emerging as one of the big themes of the past 36 hours at CERAWeek, at least as far as I'm concerned and what I've heard. Clearly, there's a recognition from the industry that in order to decarbonize energy and transportation, everyone needs to move faster. I think from a government and policy standpoint, a top-down standpoint, there's complete commitment to doing this. But I think everyone recognizes that one of the choke points in all of this is permitting, right? It's taking too long and it's slowing things down. That's one of the challenges the entire ecosystem needs to solve in the next few years, right? Unless permitting becomes much more efficient, we're just not going to move fast enough in terms of decarbonizing the industry. Localism remains important. Like a solution in Spain might look very different from a solution in Northern Europe or California. And I think the industry recognizes that it needs to make several bets before it figures out what actually succeeds.
Andre Davis, S&P Global Mobility Executive Director overseeing global commercial vehicle research and forecasting, gives his assessment for why hydrogen is capturing the attention of future-thinking fleet operators.
The main reason is really uptime. In heavy duty, it's all about uptime. Refueling is very, very short. It doesn't take a lot of time to do. In addition to that, because the fuel is fairly energy dense, you can carry a lot of it on the truck relative to whatever work you're doing. And that helps those vehicles really perform to the standards that are required. Hydrogen offers a number of differences which many people find very advantageous. For example, the vehicle is much quieter and it doesn't vibrate as much. It's much more comfortable to be in. There's also just advantages in terms of smell and just general inconvenience. So one of the numbers is going to get bigger. A lot of the sales that have been made to date are fairly small in terms of volume. Fleets are buying small numbers of vehicles to try them out. That phase is going to take a few years. In addition to that, a lot of the big manufacturers themselves haven't even released a single hydrogen vehicle to the market. So if we think about how long it takes to design and test a vehicle, that probably puts bigger volumes out still several years. And so I think we could expect to see bigger numbers in terms of thousands as opposed to hundreds probably by the end of the decade.
But when you're selling by the dozens instead of the thousands, those trucks are fiercely expensive until economies of scale come into play. Hydrogen also faces an infrastructure problem. It's not easy to transport unless you combine it with an element like ammonia. Then you need to backcrack it when it gets to its destination, which also is expensive. Or you can create a hydrogen hub for regional trucking operations, like Nikola just announced. Eventually, enough hubs may get built that a nationwide heavy-duty trucking refueling network could be in place. Abbas Gandhi, Senior Manager of Consulting for S&P Global's Refining Chemicals and Resources Solutions Group, has this to say.
Looking at the hydrogen as the fuel of the future, it will happen in phases. And I believe with what we are seeing from OEMs and even regulators, the regional application, regional haul application will be the first in terms of becoming more and more green in terms of the either hydrogen or even BEV. If the cost of hydrogen comes down, there is a real potential for hydrogen combustion engine as well to be able to compete in the marketplace. The traditional OEMs, they have the knowledge of internal combustion engine for quite a long time. The whole setup is consistent with what they have in, for example, a natural gas vehicle is in conceptually very similar to the hydrogen combustion engine. It's a risky decision, but there might be some advantages by being first. One of those advantages is the massive incentives that are out there in California in particular that may not last long. In terms of this being a sustainable solution from a government's point of view, because of the IRA, I believe cost of hydrogen will come down at the hub level, at the regional level. Those areas that hydrogen production will become, hydrogen production, green hydrogen is being supported. And I think field operators should look at in their region, is there a hydrogen hub coming online? By doing so, they can make better decision in coming years.
But whether it's hydrogen or battery electric, all of those vehicles have one thing in common: zero tailpipe emissions. That's great for the planet, right? Well, except for the fact they aren't consuming fossil fuels. Wait, what? Well, most of the world's roads are kept from falling into absolute disrepair by taxes on gasoline. No gas, no tax. As those revenues fall, how do we compensate for that shortfall so our roads don't get even worse than they currently are? Tom DeVlieshour, Senior Director of Transport and Mobility Research at S&P Global, says that anyone who uses the roads should contribute to their maintenance, but there could be some unintended consequences along the way.
It's not necessarily purely down to EVs. It's also the fact that the current fuel taxation system hasn't been updated for like many, many years. It's probably about like 2 decades. And that really is also a bigger part of the equation here. You know, many regulators or politicians are kind of sort of sitting on the fence for it right now because they are concerned that, you know, if we do talk about it publicly now, that actually it could lead to a delay in take-up of electric vehicles. But ultimately, EVs will have to pay their fair share. We can debate what kind of tax or user fee it would be appropriate, but a solution will have to be found, and probably one that is more fairer in terms of usage. So it might have to have some discrimination in terms of the vehicle weight, the vehicle sizes, or other parts, because we can't have a very large, heavy pickup, specifically an electric one with a battery in there, paying the same amount of tax as we have a very small, compact, fuel-efficient car. You know, we have to find a mechanism that really would work in reality. We haven't found the right mechanism yet. There's a lot of other issues and potential unintended consequences of this that need to be further explored. There's many trials and pilot projects going on in the US right now, and there's a lot of enthusiasm from both sides of the fence in Washington.
Speaking of unintended consequences, battery electric vehicles for now seem to be a first world solution, as many underdeveloped countries do not have a sufficiently stable grid. There's also a lot of discussion about the ESG factor and well-to-wheel dynamic of battery electrics. That while there are zero tailpipe emissions, the creation of the battery powertrain via its raw materials has a rather steep ESG price to be paid. How do we reconcile that? That's the purview of Andrew Fulbrook, Vice President of Sustainable Mobility for S&P Global.
I think the horse is bolted to a degree. I think certainly in China and in Europe, it is a bit of a one-horse race in terms of the push on BEV. It's very much underpinned by policy. But I think as we sort of shine a light and let's say illuminate the life cycle emissions of BEVs, other choices may actually prevail, and we may see some accommodation in that regarding policy changes. They come with their own environmental consequences when you get right down into the lower tier supply chain and some of the raw material areas. The environmental data is quite tricky to get hold of for many. But of course, it also has social consequences as well. And ESG is very much in the focus of the automotive industry. Really, the only way to sort of solve this is to find a supplier of information such as us that can link and show the full life cycle of emissions, certainly for the environmental piece of ESG, to truly find collaboration across the industry through data, and that will allow, regardless of the relationship, whether it's an investor to an OEM or an OEM to a supplier, that will allow the ability to make pretty important investment decisions, to identify hot spots of certainly emission hotspots within a supply chain, and to allow the supplier to fully embrace its own sustainability journey as well. And so it's a very, very complex problem that we're trying to solve, i.e. particularly the climate. This is the preserve of only a few organizations, I think, that can truly help the industry manage risk and find opportunity through this transition. Over the next few years, vehicles that are newly registered, new models, that's where the OEM's obligation lies. If there is a silver bullet, the BEV is getting pretty close to that. It guarantees 0 grams at the tailpipe, because there is no tailpipe. So one can understand, and the technology was and is available now to do that. And so it's perhaps unsurprising that policy is pushed in that direction, because it produces fairly fast results. And then there's the vehicles that are already in operation. Some of the vehicles that are produced today, which are not BEV, of course, will still be on the road in 10, 15 years' time. That's not so much the obligation of the OEM, but it's certainly the obligation of a government, because that forms part of the government's obligation and the country level obligation that you see at COP, for example. And so that is an opportunity. You can't possibly imagine every vehicle in the park being retrofitted as a BEV. That's rather nonsensical. But this would open up opportunity for e-fuels or sort of next generation synthetic fuels, where not too much modification would be necessarily required, where combustion engines could see a bit of an extended lifeline in the park. People talk about the new mobility era. I think that the transition that we're going through is an era of itself, and I think should be considered as such. But there's so much change as we go through that process, that stability, fast decision making, depth and transparency of data, and the full connection of emissions, social and economic effects of transition need to be captured by a company like S&P Global, and decisions can then be made to give ourselves the best opportunity to abate the climate change issue.
So there you have it. 5 days of insights packed into your daily commute. Thanks to you for listening. That was a lot to unpack, but I hope you all feel smarter and more informed for having tuned in. And if so, please share this podcast link with your colleagues and social media accounts. And to opt into our newsletter that provides more info on this topic and others, please visit spglobal.com/mobility. We'll be back for more Fuel for Thought next month.